and I get 1.837. 1.837 meters per second. That is the velocity of ball 2 after I hit it with the cue ball, ball 1. So now I can take this number, plug it into this equation, and solve for my final unknown, which is the velocity of object 1. All right, so let's plug this velocity into the other expression to get V1. So we have V1 is equal to 11.323 minus 0.792 times V2, which is 1.837. So times 1.837. And so now just simplifying, I can solve for my V1 and I'll be finished with the problem. So V1 is equal to 11.323 minus 0.792 times 1.837. And that gives me 9.87, so 9.87 meters per second. So what we see is that after I hit this ball towards the black ball at a velocity of 10 meters per second initially, and I notice they bounce off of each other at a 40 and 50 degree angle respectively, I now know that ball 1, the cue ball, will move at 9.87 meters per second, so it preserves a lot of its original velocity, whereas that black ball, based on the angles that they collided, is reflected at only 1.837 meters per second. So these are their final velocities after the collision based on an initial velocity of 10 at a 30 degree angle. So now you can see that using the law of conservation of momentum for a game like pool, or any game where you have masses moving at velocities at particular angles, as long as you have your two equations, you can add all the momentum before and after in the x direction, and add your momentums before and after in the y direction. You can always solve for two unknowns.